Good day, class. In this video, I will demonstrate the application of annotation objects in your working drawings using the AUTOCAD application software. Annotations in construction drawings or working drawings include labels, tags, dimensions, and callouts. In CAD, annotating can be done through commands that involve the adjustments and inputs of text, attribute definitions, dimensions, and leaders. We will start first by the adjustment of our text styles before we create our drawings. It is important to make the necessary adjustments first by using the text style command. The shortcut for text style is ST, or in phonetic alphabet, Sierra Tango. So let's type ST in our keyboard and press spacebar to execute the command. Upon entering the command, a dialog box will appear, which is our text style dialog box, as shown in this video. It is recommended that you create your own text style first rather than using and editing the default text style by the system. To create your own text style, click on the New button found on the right side of your dialog box. Upon clicking the New button, a new dialog box will appear. Here, we will set the name of our own text style. For example, I will use my initials. Any name for the text style will do. Once you are done, click OK, and you will exit the dialog box. The text style you created will be added on the styles list found on the left side of your dialog box. Click on your created text style and then click Set Current found on the right side of your dialog box to make it your default text for the text objects that you will create later on. For the font, since we are working on our formal working drawings, it is recommended that we use Arial and Regular for the font style. To show you the font name, it is similar to your Microsoft Office documents or the similar softwares that you use for creating your documents. Same with the font style, in which you can choose between bold, bold italic, or regular. For the size, you have an option of selecting the annotative box. Selecting this will make an icon appear on the left side of the name of your created text style in the list, which means that your text style is annotative. Annotative text style will make your text style relative to your paper size and will adjust depending on the drawing scale that you use in your layout. But for now, let us deselect this first. You can adjust the text height if you prefer for your text. For example, I prefer to use a text height of 200. For the effects, you can check the upside down if you want your text to be displayed vertically reversed or inverted. Clicking on the backwards will invert your text horizontally. For the width factor, inputting a higher number will widen your text, while inputting a lower number will narrow down your text. For now, we can use the width factor of 1. Obliquing angle will somewhat make your text look like italicized. For example, if I put 10 here, you will see on the preview of your text that it will somewhat be italicized or oblique to the right. But as for now, we can set it to 0. If changes are made in your settings, click Apply and then Close to exit the dialog box. We will now proceed to creating our text. There are two types of text that can be created in your drawings in AutoCAD. These are the multi-line text and the single-line text. Multi-line text is used for creating paragraphs or longer labels with its own internal editor that is like certain software, such as Microsoft Word, spreadsheet documents, and other softwares that are related. While the single-line text is used for short text, notes, or phrases. Ideally, multi-line text is preferably used for specification callouts, while single-line text is used for short labels on plans, such as your room labels, column labels, etc. I'll demonstrate first the creation of your multi-line text. The shortcut key for your multi-line text is MT, or in phonetic alphabet, Mike Tango, or you can also use the shortcut Tango. So let's type T on our keyboard, then press spacebar to execute the command. We are now prompted to create our text box. We will first specify the first point of our text box. Then, we'll specify the other opposite corner of our text box. When your text box are specified on your screen, you will notice in your ribbon that a new tab will appear. This new tab is your text editor, where you can edit the text that you input inside your text box. The settings inside your text editor tab are similar to your Microsoft Office, which include justification, bullets, line spacing, and text alignments. So let's type our text contents first. For example, I'll type multiple lines of text within my text box. Once you are done, you can simply exit the dialog box or the command by clicking somewhere outside your text box, or by clicking or pressing Ctrl and Enter on your keyboard simultaneously. Your multi-line text is now created. The second type of text creation in AutoCAD is the single-line text. The keyboard shortcut for single-line text is DT, or in phonetic alphabet, Delta Tango. So let's type DT on our keyboard and press spacebar to execute the command. Usually, if we don't set our text height using our text style command, we are prompted first to enter our text height. But since our text height is already pre-modified, this step will be skipped. We are now prompted to enter the rotation of our text. The default rotation angle for our text is 0. So if we don't wish to change the direction of our text, we can simply skip this step by pressing spacebar or enter. Although single-line text can also be used for creating text with multiple lines, however, unlike the multi-line text command that creates multiple lines in a single selection, when multiple lines are created using the single-line text command, each line will be independent from each other, wherein each line will have a different selection. Here, I will demonstrate later on after we input our text. So let's input the same text that we enter using our MText. And to exit the command once we are done typing, we can simply click outside our text box or by clicking Ctrl and Enter on our keyboard simultaneously. The multiple line text we created using our MText command can be selected in a single selection only, where everything is included as one. While, if you'll notice the text created using our single line text command, each line has a different selection, and they will be selected individually. So to apply in our drawing, single line text can be used in labeling our rooms. For example, let's type DT, execute a command, specify your first point, specify the rotation of your angle, and type your space name. For example, I'll type bedroom. You can also copy your text using your copy command and copy it towards your other spaces, such as your toilet and bath. You can also position your text using your move command. You can also edit the existing text by double-clicking on the text. Next in annotations is the creation of our attribute definition. The shortcut for attribute definition is ATT, or Alpha Tango Tango. Now, an attribute is an object that is created and included with the block definition. Attributes can store data such as part numbers, product names, and so on. This is ideally used for creating tags and title blocks. Attribute definitions are like text, but this is used with a block command. Unlike text, contents of attributes can be edited when converted into block. In creating tags, attributes are used along with drawing elements and text, which are then blocked together to create one component, wherein the attribute can be changed based on the values you enter. For example, let's try to create a door tag. So let's start first by creating the symbol using our draw tools. Let's draw a circle with a diameter of 500. Then we'll create the dividing line in between our circle. In our door tags, the text on the upper part of our tag is fixed, where we can use our text command, single line text command. We can simply type D on the upper part of our tag and adjust them. The changeable value depending on our door number is placed on the part below our tag, where we should use our attribute command. So let's type ATT and press spacebar to execute the command. The attribute definition dialog box will appear as you enter this command, as shown in this video. Set the label for your tag. For example, since we are creating door tag, simply type door underscore tag. If ever you wish to label it with more than one word, use an underscore instead of a space. For the prompt, we will specify our instruction. For example, we'll put specify door number. And we'll input our default value. Any number will do for now. This is the value that can be changed later on once our tag is converted into block. So for example, we'll use 1 for the meantime. You can also choose your text style based on the list in your text style dialog box. If you created more than one dialog box or more than one text style in your text style dialog box, the other text style will appear on this dropdown as well. If you pre-configured your text height, the text height in this dialog box will not be adjusted. You can also set the rotation of your attributes if you wish to. For the justification, since we are using tag, it is recommended that we use the center alignment. Once we're done, press OK, and then we will position now our attribute definition. Now, to completely use our attribute, we will now convert the whole object or our whole tag into a block component or a block definition. So let's select everything in our tag, then we'll use the block command using B. We'll name our block definition into door tag. And when creating blocks, always remember to pick a point. Let's choose the center of our tag as our pick point. Then click OK. You can adjust your door tags in these attributes, or you can simply OK if you wish to edit the contents later on. Our door tag is now created, and we'll try to place them in our drawings. If we wish to change the value of our door tag, we can just simply double-click the tag and the dialog box will appear. We can change the value of our attributes in this dialog box. Changing the value will instantly preview or apply it on your actual drawing, as you can see in this video. So once you're done, click OK to exit the dialog box. Next in annotations is our creation of our dimensions. But before we create our dimensions, we need to adjust first and create our own dimension style. So to adjust our dimension style and to create our new style, the shortcut command for dimension style is D, or in phonetic alphabet, delta. So let's type D, then enter, execute the command by pressing spacebar. To create our own style, click on the new button found on the right side of your dialog box. We are now prompted to name our own dimension style. For example, I'll use the same name as my text style. You can also choose whether your dimension is annotative or not. So for now, let's use standard and click continue. A new dialog box will appear. Let's start first by editing our primary units. Since we are using millimeters as our units of measurement, let's set the precision into 0, since we don't need the decimal points when we use millimeters. And in the actual practice, we cannot measure any objects below 1 millimeter easily. For our text, we can also choose the text style we created in our text style command. Choosing our text style, the text height for this dialog box will be fixed. We can also set the text color, in which later on will affect the line weights of our text, which will be discussed during your layering and line weights assignment. For the text placement, it is recommended that you place your dimension text above your dimension lines. For the text alignment, it is recommended that you align it with your dimension line. Now let us adjust the offset from dim line based on our text height. So for now, let us use 100. We'll now proceed to the symbols and arrows tab. The arrowheads are where our dimension lines and extension lines intersect. You can choose anything you want, or in most cases, we use the architectural tick. For the leader line, this will somewhat affect your leader command for specification callouts. So for now, I'll choose right angle. You can choose any arrowheads you want for your leader lines. For the arrow size, set it proportionally to your text height. For example, you can set it to 200. For your center mark, you can use 100. And for the break size, you can use 150. The last to adjust in our dimension styles is under the Lines tab. We'll set first the color into by layer, in which the color of our dimension lines and our extension lines will be changed according to the layers that will be assigned later on. For our baseline spacing, adjust them according to the proportionality of your text height. Also, the difference between the dimension lines and the extension lines. Dimension lines are where your text are placed, while the extension lines are the lines which extend from your object towards your dimension lines. So let's set everything proportional to our text height. Once you're okay with every settings or any adjustments you've made, you can click OK to exit your dialog box. We will now go back to our Dimension Style Manager dialog box, where we can see that the dimension we created will be added on our styles list. Click on your styles list, and when it is highlighted in blue, let us set it as our current dimension style, which will be applied to the new dimensions we will create later on. So click close to exit this command, and we will now proceed to the inputting of our dimensions. We'll start first with the linear dimensions. The shortcut key for linear dimensions is DLI, or in phonetic alphabet, Delta Lima India. So let's type DLI and execute this using our spacebar. There are two methods of applying linear dimensions. The first one is our point-to-point method, where we are prompted to specify our first point, then our second point, and then we'll specify the location of our dimension line. The linear dimensions are always aligned to your vertical and horizontal grids, regardless of where or how inclined your object is. Another method for using the DLI command or the linear dimension command is the object selection, in which it will automatically set the dimension based on the segment that you are selecting. For example, to use the object selection method in DLI command, let us again type DLI and execute this using our spacebar. Before we specify our first point, let us press spacebar again. We are now prompted to select the object we want to measure. So let us select this line. So we now have our linear dimension. The next type of dimension is our align dimension. The shortcut key for align dimension is DAL, or in phonetic alphabet, Delta Alpha Lima. So let's type DAL and execute this by pressing spacebar on your keyboard. The usage of this command is exactly the same way as your linear dimension, where there is a point-to-point method where you will specify your first point, and then your second point, then your dimension line position. You will notice that the align dimension is always aligned to the positions of your dimension points or the objects you are measuring. You can also use the object selection method with this command. The third type of our dimension is our angular dimension, where it is used to measure our angles or the angle of our arcs. The shortcut key for angular dimension is DAN, D-A-N, or in phonetic alphabet, Delta Alpha November. So let's type DAN and execute this by pressing spacebar on your keyboard. So for angles between two lines, we'll choose the two objects that we want to measure the angle between. And then once we select these two objects, we are now prompted to specify the position of our dimension lines. We can also measure the angle of our arcs based on its segment and radius. So let's execute the angular dimension and let's select the arc. It will automatically specify the angle. The next command for our dimension is our continue dimension command. The shortcut key for the continue dimensions or continuing dimensions is DCO, or in phonetic alphabet, Delta Charlie Oscar. This is used when we want to continue a specific dimensions without choosing or manually choosing a first point and a second point again. This is a quicker way of inputting our dimensions. So once we input our last dimension, whether linear or aligned, if we execute the continuing dimensions command, so let's type DCO, it will automatically continue the last dimensions that we enter. Or if we want to continue other dimensions rather than the last dimension we created, before we specify the continuing point, press spacebar to select the extension line of the dimension we want to continue. So let's try to select this one and provide continuous dimensions for this. The next type of dimension is our radial dimension, which is used to measure the radius of an arc or a circle. So to use this command, the shortcut key to be entered is DRA, or in phonetic alphabet, Delta Romeo Alpha. So let's type DRA and execute this using our keyboard. We are now prompted to select the arc or a circle to measure the radius. So let's select an arc, and then once we selected the object, we are now prompted to specify the position of our dimension line. The same goes with the next type of dimension, which is diameter dimension. The shortcut for diameter dimension is DDI, or in phonetic alphabet, Delta Delta India. So let's type DDI and execute this by pressing spacebar on your keyboard. The process is the same as your radial dimensions, by simply selecting an arc or a circle and then position your dimension lines. The last among the dimension types is our arc length dimension. The shortcut key for this is DAR, or in phonetic alphabet, Delta Alpha Romeo. This is used to measure the circumferential length of our arc. This is usually used for details in order to identify or determine the linear meter of our details. For example, railings or decorative elements in our buildings. So to use this command, let us input the shortcut key, which is DAR, and execute this by pressing spacebar on your keyboard. Then simply select an arc or a curved element. Then you will now have your arc length. The last among the annotations is our leader line. The shortcut keys for leader lines or leader is LE, or in phonetic alphabet, Lima Echo. So let's type LE and then execute this using our spacebar. By pressing spacebar again after the command execution will lead us to the leader settings. Let us set first our attachment for our multi-line text or specification callout. It is recommended that you align your leader lines at the middle of your multi-line text box. Next is the leader line and arrow. You will notice that it is automatically set based on the dimension style you have chosen earlier. For the angle constraints, it is recommended to use 30 or 45 degrees for the first segment, and for the second segment is horizontal. This way, your drawings will look somewhat organized. For the annotations, you have an option of using MText or multi-line text, or you can also use block references such as your tags. And also, if in order for you to avoid repeating typing a long specification callout, you can simply copy an existing multi-line text. For now, I will demonstrate creating a leader line using MText. So press OK, and then specify the first point where your arrowhead is located, and this is the first segment. Specify the second point for the end of your first segment, and then specify the third point towards your specification callout. We are now prompted to specify our text width. So if we don't prefer any changes, we can simply skip this by pressing spacebar or enter. We are now prompted to enter the first line of our text. For example, let's specify the finish of our floor, such as ceramic tiles. Pressing enter again after typing your text will exit the command. If you wish to edit your multi-line text contents in your specification callouts, you can simply double-click your text and edit it, which has the similar way as your multi-line text command. The next type of our leader line is by the use of our tags. So to create a leader line with using our tags as our callout, you also use the leader command or LE, and then go to the settings and choose block reference. Then click OK. Now specify the first, second, and third points of your leader line. And then we are now prompted to enter our block name. If we have created multiple blocks already and we don't remember our block name, we can use the question mark sub option. So let's type question mark and press enter. And then to show the blocks, the list of the block names or the names of the block definitions we created, we'll input asterisk and then press enter. These are the door tags or the block definitions we created in our drawings. So we can now see our door tag name. So simply exit this dialog box and type door underscore tag, which is the name of our tag definition, and press enter. We are now prompted to specify the position of our tags. For the scale factor, you have the freedom if you want to double or to increase or reduce the scale. But as for now, we can use scale factor of 1. For the rotation angle, you can specify whether you want your tag to be rotated or not. If you don't want to rotate your text, simply press spacebar. You are now prompted to enter the door number or to edit the value of your attributes. So you can simply type 1 or 2, then click OK. The third method for inputting our leader line is the use of copying an object. So let us set our leader into copy an object. This is used if we want the same contents to be reused in different specification callout. For example, our kitchen has the same finish as our bedroom. So once we set our leader line, we'll select the multi-line text that we want to copy. Clicking on the multi-line text that we wish to copy will automatically apply to our new callout. This can also be used for block definitions such as our tag. For example, for this door, we'll apply our tag. If you wish to edit the tags, you can also double click them and change the values. So that's all for the demonstration video for the application of annotations.